Yes, that's true.
Sorry.
It's still going.
Okay, it is still good. Okay. So how much have you done in functions? Have you done like domain range and different type of
So
functions
now
like
we're in on to
sorry,
contouring functions.
I could not get you. Sorry. Can you type and send? Okay, on to into functions. Fine. So you are doing on to. Have you done many one functions?
Yes, sir, we finished that.
Okay. Fazza, what about you? You are also doing the same thing? Okay. Fine. So we'll deal with those type of functions today. And as we all know that these are type of functions. So one many one functions. Let us deal with this first. So if we talk about one function, what happens there that for every image, there is a unique pre-image. That is, we write it like this, that for every image or element in set B, there is not more than one pre-image in set A. So this is set B, there is image, and set A, there are pre-images. So for every element in set B, there is not more than one pre-image in set A, like this. There may be any element for which there is no pre-image, that is fine. But one means that unique pre-image. So this is okay. But if we do something like this, that this is here and this is like here, and here this is like this, and then this. So this is many one. As the name suggests that many are mapped to one. So two elements are mapped to one element. So it is many one. Here it is one. Now, how do we check that a function is a one function or a many one function? So for that, what we do, we take f of x1 is equal to f of x2. And if we are able to prove that x1 is equal to x2 only, then it is 1. So if we see few questions, first write this down. I'm giving you the question. So let us start with this question. This question says a function f from the set of natural numbers to integers. So from natural numbers to integers. So set A is natural numbers and set B is integers. You know what are natural numbers? 1, 2, 3, 4, 5, 6, so on. And integers are negative as well as positive or zero also. The function is defined by fn is equal to n minus 1 by 2 when n is odd. When n is odd, and minus n by 2 when n is even. So can you tell whether it is one or many one function? Okay, Sarif, you are saying it is one function. What about you, Faza? Faza is saying many one. So can you justify both of you your point? How is it so?
We can take x1 and x2 equal to n, then it will be, then we can put f of x1 equal to f of x2, then it will be f of x minus 1 by x minus 2 is equal to x minus 2 minus 1 by 2, then it will be x minus
But
x1 equal to
but
minus
one
x2.
thing, yeah, it is okay. But one thing, why we will take x1 minus 1 by 2 and x2 minus 1 by 2? Can't we take x1 minus 1 by 2 and minus x2 by 2? Another definition. So here, if you will try to apply f of x1 is equal to f of x2, so the challenge is that that function has not only one definition, it has two definitions, depending that x1 is even or odd. So that will not help. Okay, because we don't know what to take f of x1. First one we take or second one take. What we take f of x2, first one we will take or second one we take. Then we will have to make cases. There will be 4 cases. That means x1 is even, x2 is even, x1 is odd, x2 is odd, x1 is even, x2 is odd, x1 is odd, x2 is even. So this will be quite lengthy. Yeah, Faza is exactly saying that thing. But I won't suggest that do it like that. That Faza is also telling that we will take cases. There is a better way, simple way. If you see the pattern, write the natural numbers 1, 2, 3, 4, 5, and so on. What will be f of 1? Can anyone tell me what will be f of 1? One is odd. So which definition we will apply? N minus 1 by 2. And what output we will get? 0. Correct. So both of you agree that it will be 0. If we take f of 2, so 2 is even, and in case of even, what we do, minus n by 2. So it will be minus 2 by 2, that will be minus 1. Correct, Afaza? So this will give you minus 1. What will be f of 3? Sharif, you can also tell. Faza is saying 1 by 2. How it will be 1 by 2? 3 is odd. Yeah, it will be 1. 3 minus 1 by 2 will be 2 by 2, which will be 1. What will be 4? Minus 2. That is minus 4 by 2 is minus 2. Correct. Sharif, I want you to give the answer next one. What will be f of 5? Two. Correct. So based on this pattern, we see that it is 1, 1. Because for every image, there is a unique pre-image. It is not happening like, it is not like this, that two different pre-images are giving the same image. It is not coinciding like this. So this is not the situation. So we can say that this is 1, 1. So here arrow diagram is a better way instead of taking the cases, because cases will obviously do here, but if we have a simple method, we can do like that. So you can write it now. One more thing. Faza is saying, is this method applicable for boards? Faza, you can apply this for boards also, because this is a justified method. No? As you easily see over here, that in general, you can say, you have to write it more. In general, you can say that for odd numbers, what are you getting? Like 1, 3, 5, you are getting non-negative integers. 0, 1, 2, 3, like this. And for even numbers, you are getting negative integers. So there are two different categories. So you can say that yes, and all are distinct. So it is 1, 1. So one more thing is there in the same question. There is one more concept which is called onto and into. What is onto? Onto is that the codomain is equal to range. That means what are the images you are getting? They cover the codomain, set B. And there is no element in set B unleft mapped. Whereas into range is not equal to codomain. Range is smaller than codomain. Some values are left. So can you also tell whether this function is onto or into? Onto means what is set B here? Set B is integers. So in layman language, if someone says, are you getting all the integers? So you will say yes or no. Is any integer left? As you can see, 0, 1, 2, you are getting, -1, -2, you are getting. So Faza is saying no, no integer is left, correct? So from the pattern, it is clear that all the integers will be covered, whether positive or negative. So we will say that this function is onto as range belongs to integers, which is equal to codomain. Codomain is generally given in the question. And if it is not given in question, then we take as real numbers. Here in this question, it was given. You have done inverse trig also. So there is a question which is a merge of functions and inverse trigonometry. It says, let f -1, 1 to b be a function defined by fx is equal to tan inverse of 2x by 1 minus x square then f is both 1 1 and onto when b is in the interval options are given to us. A minus pi by 2 to pi by 2 open interval, b minus pi by 2 to pi by 2 close interval, c 0 to pi by 2, d 0 to pi by 2 both open. Try this first. Should I give you some hint, or first you will try, then I will give hint? Okay. So I'm giving you the hint. Hint is that let x is equal to tan theta. Okay. So since x belongs to -1, 1, this is the value of x. So it means that tan theta belongs to -1, 1. So what will be theta in that case? It will be minus pi by 4 to pi by 4. Okay, -1 it is at minus pi by 4 and 1 it is at pi by 4. So theta belongs to minus pi by 4 comma pi by 4. Now you can simplify this f of x after putting x as tan theta. What will you get? Can you tell me? Fx, what you will get? What will be 2 tan theta by 1 minus tan square theta? Tan 2 theta. Tan 2 theta is 2 tan theta by 1 minus tan square theta. Now, here what we have to keep in mind that if this angle 2 theta is in the principal value of tan, then only we can cancel tan inverse and tan. So if theta is minus pi by 4 to pi by 4, then 2 theta will be between minus pi by 2 to pi by 2. So here it is the principal value. So you can write it as 2 theta. And finally, what is theta? Theta is tan inverse of x. So fx is equal to tan inverse of x. This is what we are getting here. Or you can also say 2 theta. So this value is minus pi by 2 to pi by 2. And this can be 1, 1 and on 2 if all the values are being covered once. So it is possible if we take this set B, which is the codomain, this set B is the codomain, as the range. So this range should be B. So minus pi by 2 to pi by 2, which is option A, is your answer. Just write it down. And if you have not understood any step, you can ask, I can tell it again. So we come to the next question. Here it is given that f is function fx is equal to x cube plus 5x plus 1. You have to check whether it is onto or into many one or one. Both things. Here, codomain is not given. Domain is real because it is a polynomial for all x belonging to real. Codomain, if it is not given, then it is real number. So you have to check this. Just try this out. It is a cubic polynomial. One thing here we need, which is basically from application of derivatives, which you will do little later in this class. I will explain that thing here, that if fx is increasing function, then its derivative, you know, na? You use derivative. F dash x is greater than 0. And if fx is decreasing function, then its derivative is negative. So you have to take help of this concept little bit. So as I gave you the hint, you have to differentiate this. Can you tell me what will be the derivative of this function f dash x? This is a simple differentiation. What is the differentiation of x cube? So as I saying 3x square plus 5 plus 0, correct? So this will be 3x square plus 5. X cube will be 3x square and 5x will be 5, 1 is 0. Sharif, it is okay? Is it clear? You got unmute for a moment, but I couldn't hear anything. So when you get unmute for a small span of time, to keep unmute so that I can get to know what you are saying. You just unmuted and muted and I don't know what you said. Anyways, so 3x square plus 5 is always greater than 0. for all x belonging to real number. It is never negative because you are squaring the x. So it is positive and you are adding 5 to it. So it will be positive. So if it is always greater than 0, then fx is increasing function. Now, if the function is increasing, then x cube plus 5x plus 1 is a cubic function. So if you see at one end, that is at x approaching minus infinity, this function fx will approach minus infinity as it is cube. And if x approaching infinity, then fx will approach infinity, because it is minus infinity cube is minus infinity plus infinity cube is infinity. So the function is starting from minus infinity to plus infinity, cutting it at somewhere, and we don't know exactly where it is cutting it, but maybe something like this. It is a function like this. So cubic functions are of many types, like it could be a function which is like, as we see, that could be like this. It could be a function like this, just touching it. And it could be a function, this, which I have drawn first. But these two cases are not acceptable. Why these two cases are not acceptable? Because in both of these cases, the function is increasing, then decreasing, then increasing. But what we are getting that here function is always increasing. And here also the function is increasing, decreasing, increasing. So since we want a function which is only increasing for all x belonging to real number, so that cubic function is like this. This is the cubic function, right? Which I have drawn. So this is the function which is acceptable. This has only one point where it is cutting the x-axis. It has only one real root, and it does not have 2 or 3 real roots. Now from the graph, we can say that it is 1, 1, because it will intersect, because any line parallel to x-axis will actually cut it only once, and it is onto also, because it is from minus infinity to plus infinity, all the values. So we say it is 1, 1 also, it is onto also. So this is how derivative will help you in solving. So you can write it. Written. Okay. Let A equal to x belonging to real number such that x is not a positive integer define a function f a to r as fx is equal to 2x by x minus 1. Then again you have to find out that f is 1 1 many 1 onto or into. So this you have to tell. Have you tried? Would you like to share how you are doing it? So first, 1 1 many 1 you can do like this, that f of x1 is equal to f of x2, and then proceed. So it will be 2x1 by x1 minus 1 and 2x2 by x2 minus 1, and 2 will cancel. Then cross multiply. So it will be x1 x2 minus x1 is equal to x1 x2 minus x2. So this will cancel and you will get x1 is equal to x2. So yes, it is 1 1, right? It is 1 1. For onto, how you will do? You have to find the range. So first write this, try for onto, then I will explain for onto also. So you take fx as y. So y will be equal to 2x by x minus 1 as it is given. Then you cross multiply. So you should also suggest, even if you tell something wrong, then also it is okay, but you should also uh, interact so that we will have clarity that how to correct in case of anything which is not being understood properly. So you can write it like this: xy minus y is 2x. So xy minus 2x is y, and x you take common, y minus 2 will be there, and this is x. So what is the way of finding range? That y is a function of x is given, and you find x as a function of y. So after finding x as a function of y, your task is that you see that what values you can take. Okay. So as we know that here y cannot be equal to 2 clearly, because for that if we take y equal to 2, then x will not be a real. So we have to say that y is not equal to 2. Then x is real. Now, if we see the question, it says that the codomain is real number, right? The codomain is real number. And we are not taking 2. So in that situation, 2 is a value which is being eliminated from the real values. So the codomain and range are not equal. So we say that there are other values may also be there. Yeah, Faiza. So it will be into, because codomain is real number and range is not real, because 2 you can't take. Some other values also you may not take, because x will not be positive integer, but we are not discussing about that. So it is into. So let us come to the next one. If the function f r except 1 comma minus 1 is a defined by fx is equal to x square by 1 minus x square, is surjective, then a is equal to, options are r except minus 1, 0 to infinity, R except -1 and 0, R except -1 and -120. This is R except -120. So you know what is surjective? And this is Faza, surjective means onto. Another word of surjective is onto. This is 1 second. -120 like this. Yeah. So injective is a word. Injective is another name for 1 and surjective is a word which is another name for onto. And a function is called bijective if it is 1 and onto both. So they are saying that if this function is surjective, which means it is onto, then A is equal to. So the A is actually the codomain. So you have to find the range of this one, and the range will be A actually. So indirectly they are asking the range. You can share how you are trying, and if you're facing any difficulty at any step, you can share. So we can, instead of doing the whole solution, we can in between try to resolve the difficulties step by step. Okay, Muhammad Sharif saying it is D. Okay. So can you tell Muhammad Sharif how have you approached this question? So I
Yes,
think first, yeah.
so can you, so I
Yeah.
just took f of, I just took, I just took x as my minus of 1 equal to -1, then it did 1.
No, if you have to find the range, you start from here, na, like y is equal to x square by
Yes,
1 minus x square. Okay, then what you do?
yes, sir. So I took excess. Yeah, I took excess my 1 8 1 1 2 minus.
So not x. X we will see later. Right now, we have to, one thing we have to keep in mind that when we want to find range, generally what we do, we express x in terms of y. So earlier it is given y in terms of x. So our first task is to express x in terms of y. So if we want to express x in terms of y, so what we will do? We will of course cross multiply like this. We did this earlier in one question also. And then what we will do, that y is equal to x square into 1 plus y it will be. So x square will be equal to y by 1 plus y. So this is what we will get here. Now this is actually greater than equal to 0 because x square it is. So a square of a real number is always non-negative. So it is greater than equal to 0. Now we apply wavy curve, that is sine scheme. So there is a point 0 where the numerator is becoming 0, and there is a point minus 1 where denominator is becoming. So this minus and 0 is the 0. So it is positive, negative, positive. Then how to do? What will be the answer then? Since we want this to be greater than equal to 0, we will take the region minus infinity to minus 1 open, union 0 to infinity close. 0 is closed because it is included, because here numerator is 0 and here denominator is 0. So this is answer, but answer is given in a different form. So we will say that another way of writing is real number except. So you ignore the values from minus 1 to 0. So you can say this can also be the answer. Is it okay? Faza and Sharif, is it okay?
Yes, that's fine.
Okay, so just write it down by noting each and every step clearly. Next question we have is, let A is equal to 1, 2, 3 till 10, and F A to A be defined as f of x equal to x plus 1 if x is odd and x if x is even. Then number of possible functions g A to A such that g of f. Do you know composite function? Do you remember? Have you done composite function? This is composite function. Have you done it? Oh, Faza is saying that you have not done it. Okay. So I can't give this question. Sorry. I'll have to erase because this is a question of composite function. So you'll do it soon because one, many one, onto, into, you have done. So next would be composite and inverse functions. Okay. So we come to the next question. Let A is 0, 1, 2, 3, 4, 5, 6, 7. Okay. Then the number of bijective functions. Number of bijective functions. Bijective, you know, 1, 1 and onto, as we discussed above. F A to A such that F1 plus F2 is equal to 3 minus F3. Is equal to, fill in the blanks. So since it is 1, 1 and on 2, but you have to think that this is a set A and you have to map to another set which is same A. So 0, 1, 2, 3, 4, 5, 6, 7. These are the values here, and here also 0, 1, 2, 3, 4, 5, 6, 7. Now there is 1, 1 and on 2. That means 1 will be mapped to 1. It won't be like multiple pre-images will be mapped to 1, and all the values will be covered. So keeping this in mind and this condition, which can be written as f1 plus f2 plus f3 is equal to 3. So what values can we take so that the sum of three numbers is 3, and the numbers should be from 0, 1, 2, 3, 4, 5, 6, 7. So it means that the numbers are 0, 1 and 2. Then only you will add them up and you will get 3. No other possibility is there. Till here you agree? No other possibility is there such that if you add 3, you will get 3. Okay. Okay, Faiza. Sharif, do you also agree with this? Faiza is saying 3 plus 0. But Faiza, we want three numbers, no? F1, F2, F3. So we can't take two numbers. 3 and 0 are two numbers. We want three numbers from them such that they add up to 3 and they are different. You can't also say that 1 plus 1 plus 1 because it is 1, 1. You can't take image of same again and again. You have to take different. So if you want to take three different numbers from here so that they add up to 3, the only possibility is 0, 1, 2. Sarif, what about you? Do you agree with this?
Sir, we can also, sir, should it be different numbers?
Yeah, it is different numbers from A, not beyond A. Is it okay?
Yes, sir.
Okay. So one thing is that now if you want to take 0, 1, 2, which will be going where? Like 0 could be here, 1 could be here, 2 could be here, or it may be like 0 could be here, 1 could be here, 2 could be here. So many ways are there. So if you remember permutation and combination, so if you want to allot three values to three different baskets, so the number of ways is actually 3 factorial. 3 factorial ways this can be done. So this is 6. This is the first thing. Now what is remaining? 0 and 4, 5, 6, 7. What are their mapping? If we talk about their mapping, F1, F2, F3 is done. Now we have F0 and F4, F5, F6, F7. So 0, 1, 2 have already covered. So we have 3, 4, 5, 6, 7 remaining in the images. And in pre-images, 0, 4, 5, 6, 7. So if we want to again distribute these numbers in these baskets, so such that only one goes in one basket, because 1, 1 we have to keep in mind. So the ways is 5 factorial. Number of ways would be 5 factorial, which is equal to 120. So this is the next part. So total number of ways will be, if we combine both the concepts, total number of ways for those 3 and these 5. So it will be 6 into 120, that will be 720. So this will be your answer. So you can write it from here. This I think you might have written. So you can write this one. Okay, done. So let us keep till here in today's class. We'll do further other topics in the next class.